The following is the video solution from JSDT Solutions. Question 3 says, given the following geometric sequence, and we can see it's in terms of x, calculate the sum to infinity. So with the sum to infinity, remember that our formula is the sum to infinity is equal to a over 1 minus r. So we just need the value of a and r. So a is the first term in our geometric series, which is 24 over x. And r is, so we'll find r by saying term 2 divided by term 1 or term 3 divided by term 2, which honestly looks easier in this case. So I'll just say term 3, which is 6x divided by term 2. And so this simplifies to 1 over 2x, or we could just call this x over 2, okay? The 6 cancels in the numerator and the denominator. So this is what we have, and we're just saying the sum to infinity is equal to a is 24 over x divided by 1 minus x over 2. Okay, so with the 1, you can rewrite 1 as 2 over 2. So this is equal to 24 over x divided by, and that is now 2 over 2 minus x over 2. So the denominators stay the same, they are 2, but then this is now 2 minus x in the numerator, 2 minus x. And because we are dividing, we can simply just tip and times. So we leave the first fraction the same. And so when dividing, we tip, meaning switch the numerator and denominator, and then change this division to a multiplication. So tip and times. So this is equal to, and I don't really see common factors, okay? So I'm just going to say 24 times 2 is 48 over an x multiplied by 2 minus x. So the x is going to multiply to the 2, giving a 2x, and to the negative x, giving negative x squared. And that is the sum to infinity. It's also in terms of x. So that is our answer. Moving on to the next question. Question 3.2 says, write down the values of x for which the sequence converges. So the sequence will converge. If it's a converging series or sequence, it will converge when r is greater than -1 but less than 1. Okay, so we just need to find r. We already have r. It's x over 2. So in place of r, just substitute x over 2 is greater than -1 but less than 1. Now, we're trying to just solve for x, find the values of x, okay, for which the series converges. So just multiply through by +2 to get rid of this 2 in the denominator. So it's really just two inequalities, but they've been written together because, you see, we're saying value is greater than -1 but less than 1. So because they were within the same interval, they were written together. So it's still two inequalities. It's still where r is greater than -1 or r is less than 1, but it has been put together. So this is what we have, and we're just solving for x. So therefore, x is greater than, that becomes -2, but less than 2. The signs do not change because we did not multiply or divide by a negative value, and that is our answer. Moving on to the next question. Question 3.3 says, for which values of x will the series increase? Okay, let's take a look at our series and just see, what it's doing. So we have 24 over x, 12, 6x, that's 3x squared plus, and then we just keep going. So we need to find out the values of x which it will increase. What controls these terms, like the next term that we keep getting, right? Every consecutive term, or controls that? It would be the ratio, the common ratio. That's what controls what the next term is going to be. It determines that. So if we have to multiply by a value that causes the next term to become less than the previous term, then it starts to decrease. So we see that we can actually control this using the ratio. Because you can look at it for a while and try to control it from here. It may just be because, you're going to start thinking, what can I make x so that it starts increasing? Okay, I see that with this, right, we have something like 6x and then 3x squared. You see how I'm just focusing on the coefficient, right? 6 is a number greater than 3. So we can see that, okay, depending on whatever x is, it will probably be generally decreasing. But I don't want to now look at it from there because it's going to be really complicated. Let's just focus on the thing that determines each consecutive term, which is the ratio. The common ratio R is x over 2. And now we can actually look at what that is doing to each term. X over 2. So what should x be so that these terms start to increase? Well, this is a whole thing about numbers and really fractions and how fractions work. This is x over 2. You see, with these numbers, if you multiply, let's start like even at 12, okay? If you multiply this by a number that is, let's say, a fraction, a proper fraction, which is a fraction where the numerator is less than the denominator. So let's take a number less than 2, okay? So that would be 1. For example, 1 over 2. And you keep multiplying the previous term by a half to get the next term. Look at what's going to happen. You start at 12, then you have 6 times a half, then you have 3 times a half, then you have 3 over 2. What are the terms doing? They are decreasing, and we don't want that. We want it to increase. So that's what I mean by it depends on the kind of number you multiply, okay, to that previous term. So if you multiply it by a proper fraction where the numerator is less than the denominator, that's where it's going to start decreasing. So we want it to increase. So we need to ensure that we multiply it by an improper fraction. And in this case, this R can only be improper if x is a value greater than that denominator of 2. So if it's numbers like 3 over 2, can't really be 2 over 2. 2 over 2 is 1. And if you just keep multiplying by 1, it's not going to go anywhere. It's just going to stay exactly the same. But if you multiply by a number like 3 over 2, or even 2, which is 4 over 2, then they will start increasing. See, 12 multiplied by 4 over 2, which is 2, is 24. And then the next term, times 2, is 48. And you keep moving up. Okay, so that is how we would control it. We can focus on R since R is what you multiply to the previous term to get the next term. If we ensure that that value of x, okay, is a value greater than 2, so it becomes an improper fraction, and so it's going to make your terms increase. Okay, so that is our answer. I was looking at R equals x over 2 and determining that if we want this to increase, R simply needs to be a value greater than 2. And that is our answer. Okay, so this method is more like analyzing the way the expression is going to behave, okay, based on what R is. So it's more of an algebraic breakdown of it. Okay, so this is our answer. Moving on to the next question. Okay, and now they say if x is equal to 4, see, that's a value greater than 2, determine the sum of the sequence to 15 terms, okay? So we just know x is equal to 4. Let's take the sum. We need the sum, but we only have the sum to infinity. So we just need the value of a and r. So a is 24 over x. R is x over 2. Okay, let's determine what r is so we know which formula to use since this is a geometric sequence. So we have 4 over 2, which is equal to 2. Okay, so r is 2 now. And because r is 2, this is a value that is greater than 1. So let's use this formula. Sn is equal to a multiplied by r raised to the power of n minus 1 all over r minus 1. Okay, this is where r is greater than 1. That's the formula I'm using. So the sum of how many terms do we have? 15 terms. So sum of 15 terms is equal to a, should have found the value of a already. This is 24 over 4, which is equal to 6. Okay, so 6 multiplied by r, which is 2, raised to the power of 15, minus 1 over 2 minus 1. So let's just substitute and find the value. And we finally get the sum of 15 terms is 196,602. And that is our answer. Okay, so that is it for question 3.